Hi, good day all of you. Welcome to our session. Welcome to our channel Intelligible Tutorials. In this today's session, I am going to describe about the example of the recursive best first search algorithm. In the previous class, we have described already about the greedy best first search and recursive best first search algorithms. Now, with the example, we will see the recursive best first search algorithm, how it will work. Now, we are going to see. Let us see. Here, in this example, the root node is starting from the A. Here, the value at the pathcast value at the root node is 366. The f of n value is 366 and it expands all the three nodes. Okay, so S, T, Z, S 393, 3T for 447 and Z 449. And which one is minimum here? F of n is the minimum value among all these. Minimum is 393. So it expands all the 393. A, F, O, R we got as the successors. Okay, so A value is 646, F value 415, O 526 and R 413. So here in this particular level, which one is minimum? 413 is minimum. So it expands 413. It got C, P, S. C value 526 and P value is 417 and S value is 559. Now look at this. By expanding this one, 646, 415, 526, 413, it looks to the previous level. Is there any minimum value? Here it is, the minimum value is 413. Before this, any minimum value is there, minimum than this, then it goes and tries to expand that. Before, for 413, there is no minimum value here, so it is simply left in this level. But again, it checks here. 413 here R value, it expands all. So here it is getting 526, 417 and 557. So which one is minimum here? 417 is minimum. So before expanding each and every node, it looks to the previous level. So it looks to the previous level, it is having 415 as the minimum value. So it stops expanding this particular P, directly it is expanding the F value. See in this particular diagram, I am showing F is expanded here. So successors get as S and B and R as C, P, S 526, 417 and 559. Okay. And now which one is minimum in this level after expanding SB? Here is nothing but SB 591, 450 and P is the minimum here. There is no minimum value here in the previous levels than 417 in this level. So 417 we have to expand his it L, K, M we got, that is 418, 615 and 607. Again it will go to the previous level and check any one minimum than this particular 418. So there is no minimum value, directly it expands this 418. Like that, before expanding at each and every level, at each and every node, it looks to the previous level, recursively searches for the previous levels as there any minimum value is existing than the previous one, the current one, whatever it is going to expand. Look at once again, at the A366 it has begun, expanded STZ, the minimum one is 393, it expands and again it got AFOR, 415 is the minimum here, checks the previous level, there is no minimum, expands the 415, okay, so, sorry 413 is the minimum here, there is no minimum in the previous level, so expand 413 here, it got CPS, 526, 417, 559. So minimum is the 417. Before expanding this 417, again checks the previous level. 415 is there at the F. So expands 415 and again it expands the R already expanded CPS. Now after expanding the what is the current value here? CPS 417. So after expanding 417, LKM it got, coming to the previous level, checks is there any minimum value, then 418 is the L, there is no minimum value and it expands directly like this. So that each and every minimum value in the tree is completely having the successors. So that's why it can often regarded as not a greedy and not a depth first search current fringe expansion. It's a complete tree expansion. Even it generates excessive nodes, it is better, complete and as well as optimal. But suffers from one drawback, that is nothing but excess node generation. So this is nothing but recursive best first search algorithm. So in the coming videos we talk about some more heuristic techniques. Thank you.